Using different materials, we can generate different colors. Welcome at Riverdi University. My name is Kamil and I'm CEO and founder of Riverdi. Today we'll be talking about OLED displays. OLED displays are a little bit different than the TFT displays that we normally sell, and actually Riverdi do not sell standard OLED displays. We sell them as a custom modules only for particular projects. So if you require OLED display in your application, please contact us and for sure we'll be able to find a solution for you and work like right display for you. Anyway, because we share the knowledge about displays, we have today's university lesson about OLEDs, because it's important to understand how they work and how to use them, and just acknowledge this fantastic technology that exists. And for sure in the future we will have standard displays based on OLED technology as well. So here we have a short agenda. We'll talk about basic rules, how they are built, how they different from TFT modules, a little bit about physics, and then we'll talk about application rules, how to use OLED displays. We will talk about passive OLEDs. Then we'll see the comparison between OLED technology and STN, which is a monochrome LCD, and a VFD, which are the vacuum displays. Pretty old technology, but still we can find some displays on the market use this this technology. We'll talk about active OLEDs that are AMOLEDs and super AMOLEDs, and last we will talk about interfaces for OLED displays. So let's jump first here. So OLED is abbreviation from organic light emitting diode, so like a LED, just based on organic materials. The emitting light is pretty much the same as with the LED, just the materials used here are different. It's not a, let's say, silicon based, but rather organic based layers. And as you can see, the build and construction is pretty simple. The physics here is like in any LED diode or laser. So we have the recombination of the electrons. So with the currents, they go to the higher levels, energy states, and then they go to the lower levels and they emit the light. Yes, and using different materials, we can generate different colors, and this is different than in TFT. As you may remember from our TFT sessions, we were talking that the TFT, or the like LCD in general, is just blocking the light from the backlight. So usually the backlight in TFT is white, then we block the light, or we transmit the light. And to achieve the color in a TFT, we need to use a color filter. Yes, normally it's like three color filters on the top of the TFT screen, which is RGB. Here it's different. Here we have a material that emits the color itself. So using different materials, we can emit different colors. Yes, pretty much all the colors. Of course, if we have full color OLED display, which will be typically AMOLED displays that you can see nowadays in mobile phones or tablets or even laptops or TV, of course, they use different cells like RGB cells or RGBW, something like that, and then the colors are mixed. But as I mentioned, the OLED is emitting light itself, so we don't have any backlight. And we'll skip to the next slide here, and you can see a simple comparison between TFT display and OLED display. So the first thing that is always noticed is that OLED display is way simpler. Yes, so we have way less layers than in a TFT. As you remember from TFT, it's pretty complicated. So first we need a backlight, then we need some diffusers, light guides to prepare the light, and then we have, of course, the polarizers. We have a TFT itself, which is, let's say, simplified here. And then we have a color filters that I mentioned already, and we have a top polarizer. And with all, as you can see, it's very simple construction. So basically, we need a base, as always, in every, like a backbone for a display. But then we have the emission layer and some conductive layers on top on the bottom. In a passive display, PMOLED, this is very simple compared to monochrome display. With active matrix, it's more like a TFT, so we additionally will have transistors in the cells. But in the simplified version, we don't have a transistors, just simple layers. And as you see, there is no color filter and no backlight. Yes, so we have no back and no front layers here, just middle that is emitting light itself. And this gives us a really big advantage. So I would say that of course it's simpler, so it's like maybe cheaper to build in a mass production OLED displays, or should be. It's not always the case, but if we don't have a backlight and we don't block the light, that means if we don't emit any light, we have a true black background, and this is like a huge advantage of the OLED displays, where we have a contrast in very high values. So the OLED display is like a perfect display to achieve high contrast. If we don't have a reflected light, or like if we decrease the reflected light, we don't have the light that is coming from the backlight because there is no backlight. And if you ever seen the OLED display, I think most of you have seen that. It's especially seen if you will go to some like TV store, and you will see OLED TV, particularly from LG or Samsung or other brand. You may notice that the contrast there is very high, and the black is true black. It's, I would say, even unnatural thing to see, that we will have, usually the companies there use special movies prepared, and let's say we have like a cosmos or something, and the sun in the middle, and the background is black, and it's truly black. And it's worth to see, it's different than a TFT. If you have TFT next to the OLED display, you will notice the differences, that the contrast in OLED is way higher, because there is no backlight and no issue with the light that is going through TFT always. Yes, a little, but always. So that's the main difference. So here we have the main advantages of OLED displays. So as I mentioned already, we have excellent contrast, very high contrast. As you see, the background is really black, and it looks like that in real as well, not only on the photo. So no backlight, I mentioned that as well. So high brightness, we can achieve pretty high brightness of the pixels in OLED. We have fantastic color reproduction, that's true, because we don't use the color filters. We are able to generate very, let's say, saturated colors in a wide gamut. Typically, OLEDs are the widest gamut color on the market, and it's really superior to typical TFT. Of course, we can achieve this with a TFT, with a special color filters or quantum dot filters. This kind of, let's say, enhancements of the TFT, but in general, OLED will be superior here without any special layers, anything like that. So it's true black, it's related to the contrast. Super viewing angle, that's another advantage over the TFT. If we have a typical TFT, a TN display, we discussed this already, we have a grayscale inversion, for example, from one viewing angle. Then we have displays like IPS or MVA types, which we see from all the viewing angles, but still the viewing angle will be like 85 degrees, 87, or the best would be maybe 89 degrees. Here in OLED we have 89 degrees, just like that, without anything, because it's like a LED diode. Yes, so it's emitting the light, and we can see this from all the viewing angle exactly the same. They can be very thin, as we showed. The layers, they are only few, no backlight, no front layers, so they can be very thin, very light. They can be curved. There are some applications we will show here. You maybe have seen already the, for example, Samsung mobile phones that can be like foldable. We will see it here today as well. So we can build OLED on the elastic surfaces that we can bend, for example, or curved. They have a low power consumption. If we have a LCD or a TFT, we need a backlight. Backlight is consuming a lot of power typically, because the backlight that we have in a TFT and the light that we see from TFT, they are like way lower, because the light is being consumed by all the layers that TFT has. So the polarizers, the color filters, diffuser, everywhere we lose a little bit of power from the backlight. So we need a lot of power to really have bright TFT. And with a OLED, we have just straight light from the pixels itself. So the power consumption can be low and lower than in a typical LCD. And we have a very wide operating temperatures. As you see, we can go as low as -40. With OLED, there is no mechanical issues like with the LCD, where we were talking about monochrome or TFT. We're talking that we have a real liquid crystal inside the cell. So in low temperature, the liquid crystal become close to solid, or the crystals cannot move anymore. So typically for TFT we have -20, -30, and in some special cases we have -40. But for OLED it's no problem to work even in -40 like for typical LED. On the other side, with the high temperatures, you need to be careful, because it decrease OLED lifetime. Yes, so you need to check in a spec and maybe contact manufacturers if you require high temperatures for your OLED. If it's like short periods, then it's fine. But if your OLED display need to work constantly in a high temperature, let's say above 50, 60 or 80 degrees, then it's worth to check how it will affect the lifetime of an OLED display. It affects more than typical TFT. Okay, so let's go further. Some disadvantages. Still, OLED technology is not very wide used, despite the consumer products. Yes? So in mobile phones, tablets, laptops, we already have a lot of use cases. In an industrial, I would say, application, still is like growing market, but not very mature yet. Yes, some of the problems are related to the patents. So that's why we are still waiting for like mass adaptation of OLED displays, which I believe are fantastic. We may have a higher power consumption, especially if we have like a white background. So if we want to, on OLED display, let's say browse something, and we want to have a full white background, then we need to power all the pixels, yes, or pretty much all of them. That means the power can be high, sometimes higher than the TFT. Another case is like this one. If we have like a black background, so that means all the pixels are switched off here, and only few are on, so the power consumption will be low. Okay, so there are only few disadvantages. They are, I would say, minor for use case for OLED. Here we have OLED lifetime. It's a chart from our partner WinStar. Company from Taiwan, and as you can see, they measured how long the display can be displayed. In the past, like maybe 10 years ago, there were problems with the OLED display. First, OLED displays on the market, particularly not from WinStar yet, they had a very short working lifetime. Yes, so it was like 10K hours, so 10,000 hours, and the problem was that let's say the brightness decrease even when they are not used and they were just on the shelf. So I remember some customers that I was talking to, and I was convincing them to use the OLEDs, and they say, no, I bought some OLEDs like say 3 years ago, I didn't use them and I wanted to use them now, and they are not working, or the brightness is very low. So these were the first OLEDs. They had a lot of issues, but later the process was improved, particularly by WinStar. They did a lot of work to really extend the lifetime of OLED, and here we have some calculations and report where they like use the higher temperature to speed up the process, and the result from the calculation is like 100,000 hours, yes, a little bit over, so 100K hours, which is very, very long. For industrial TFT displays, we typically have 50,000 hours lifetime. Lifetime is calculated until the display has a half of the initial brightness. Yes, it's the same for OLED, same for TFT. So when you say the display is 50,000 hours lifetime, it doesn't mean it will be dead after 50,000 hours. it means that by average the brightness will be in a 50%, and here it will happen after the 100,000 hours, which is very, very long. It's like 15 years of continuous 24-hour work. Yes, so if we sometimes switch off our display, which is normal use case in most industrial applications that it do not require 24 hours, we can expect this display to work very, very long, even over 15 years. So I would say that the lifetime nowadays with a good manufacturer like WinStar is not the case anymore. Okay, so let's talk about the adaptation of OLED displays, because with a TFT, again, I will repeat that maybe we have a backlight. So if the backlight decrease in the brightness, all the display decrease in the brightness, yes? But here we have like every pixel is a backlight itself, it's emitting light. So if we have a lot of displays pixels next to each other, and we use them, and once we use them, the brightness decrease, it decreases according to use time, yes? So if we have a pixel that is switched on longer than the next pixel, the first pixel will have after some time a little bit lower brightness. So you see 2 pixels here, they are moved aside, and this image should be prepared in a way that we should not see a big difference right now because they are moved aside. Our eyes, let's say humans, are very good. Yeah, we can recognize the colors very well, but the brightness we cannot recognize. I mean, we cannot tell what's the brightness level, something like that, but we are very good at comparison. Yes, so when we move 2 pixels next to each other, we clearly see the differences between, and this is the case of an OLED display. So if we have 2 pixels next to each other, there may be some problems that after some time, some of them will have just a little bit lower brightness, and we will see the differences, yes? So it's calculated, and the coefficient here is called a Weber coefficient. So it's like a threshold value of the contrast where we see the actual differences between 2 pixels that are next to each other. Yes, so we can calculate this, and here we have the real example. So it's just like a showcase. So if we have let's say a display, OLED display, this is like one screen, this is the second screen, and normally let's say we have a watch there, yes, like showing the time, and we have the arrows moved around, and we have the circle, and let's say for most of the time we have this image, yes, and sometimes we go to our menu and see something else on our screen. Then after, let's say, maybe some years of usage or months, we may have a situation where the circle brightness will decrease a little bit lower, like you see here. Of course, this image is like specially prepared to show it strongly, and then the arrows will have a little bit higher brightness, but still a little bit lower than the normal, yes, the background, which is not used that often. And this is something that we may see on OLED displays after some time. So the use case here would be to switching the colors. So that means we can like switch the background, let's say, to be like in a negative way. Yes, so let's say for 1 hour we have a watch like this, and for another hour we make the background on, and then we switch off the watch itself. Yes, so we try to keep the pixels in an on state all the time. It's not maybe very important. In most of the cases you don't need to be worried about that. But if you have something like, as I said, 24 hours information in some place of your display, you may want maybe to move it. Let's say, yeah, switching off. Okay, so you can also move this watch, yes, from time to time. Yeah, we can use entire display all the time, of course. And another way is to implementing a controller that use a grayscale. This is more complicated. I have done this once in my lifetime only, working with OLED displays where we needed to calculate the time of the pixels where they were switched on, and it was done in a controller, in a microcontroller that was driving this to use the grayscale that was in the display to change. So I knew that this pixel is long, and I knew the function, how it will decrease the brightness. So we were able to manually increase the brightness in this area to keep the display all the time with the same brightness. But it is very, I would say it's complicated. It required a lot of programming power. So normally it's easier maybe to move your screen around. Okay, so now we know some advantages, disadvantages, and how to use the OLED display. Let's talk about two main types of OLEDs. First one is a PMOLED, which is a passive matrix OLED display, which is very similar, I would say, to STN, so monochrome displays. So we don't have transistors in the matrix. We just have here light emitting pixels connected to the matrix that is powering the pixels. Yes, that's it. Limitation here, typically this kind of displays are monochrome, so we have just one color like here, white, or two color like here. So we have a blue and yellow in this case, but actually it's area color. Yes, so this whole area is only blue, and this top area is only yellow. So this is not a two-color display, just like two-color area color. Yes, so we cannot make a yellow here. And then with passive matrix OLED displays, we can also make a full color displays. Of course, no color filter, as I mentioned, we have color pixels there, but they are small. Yes, so limitation here is like with STN displays, we cannot make a large displays because resistance of the lines will be too high, and we will see a big differences in the contrast and in the brightness, depend which pixel we will switch on. So we only build passive OLED displays like maybe 1 inch or 2 inch for color, and maybe 3, 4, 5 inch, but they are rather like panoramic displays. So I would say the 5 inch is like a limitation that is on the market right now for passive OLED display, but only for monochrome. For color, as I mentioned, maybe 2 inch will be maximum, or 1.5 maximum. Yes, they are cheap to produce. They do not use the transistors, and they are pretty cheap to customize. Yes, so if we want to build our own display, it's like in STN. We just need to make a new glass which contains only the ITO layers, and maybe the tooling for making this kind of display will be like $20,000, something like that. But if we want to make an active matrix OLED, or like a TFT, then we need to invest in the masks that will make a transistors, which is very expensive. Yes, could be like starting from $200,000, $500,000, or even $1 million to make a mask, so to customize. So with a PMOLED, we are able in most cases even customize the display. For the active matrix is very expensive. Okay, so let's see right now some comparison between the OLED, actually the passive OLED, typical OLED, STN, so monochrome display, and VFD, so vacuum fluorescent display. Like as I mentioned, this is old technology. So as you see, the build of OLED again is very simple. So we have just one layer, just base glass, and that's it. In STN, a little bit similar to the TFT, we have a lot of layers. We need the backlight, we need the polarizers. Yeah, we need more layers, so it's more complicated. OLED is very simple, it can be very thin, as we mentioned. And here we have the real photo, how it looks. So we see the OLED, STN and VFD, and we see this from the viewing angles. Yes, so again, I would say OLED is the winner here. It has the best contrast and also the best viewing angles. Yes, so it's like a perfect display from optical point of view. As you see, STN, from some angles we are not even able to see the image. If we go to the TFT, it will be similar. We need to use technologies like IPS to see it from the all viewing angle. For OLED, we have it just like that. Yes, so it's a really good display optically. Okay, so we have a PMOLED, so passive matrix OLED, and we have of course AMOLED, which will be active matrix OLED. So it's like going from a SDN monochrome displays to the TFT displays. Yes, so to the active displays with the LCDs. Here we have the same, so we add actually the transistors. Yes, in every pixel right now, like in a TFT, actually the substrate layer, so the backbone of the OLED AMOLED display is pretty much the same like in TFT. We have just the transistors that are switching on and off the pixels. We don't have the liquid crystals, so instead of liquid crystals, we put on top organic light emitting layers, and we switch on and off the diodes, let's say, on top of this. So the technology is a little bit different, a little bit similar, I'm sorry, to the TFTs, and that's why investing in a tooling and making a new display is so expensive. It's comparable to the TFT. Okay, so these are some first devices that were on the market like probably over 10 years ago or 15 years ago even, with the OLED AMOLED displays. And here we have latest, let's say, example, yes, of Galaxy Fold and how it's being tested. Yes, so this is the Samsung video show showing how let's say they test, at least how they market this testing, that you can bend the display. So this is elastic AMOLED display. The whole surface is a display. It's not like in the middle we don't have a display, just the connection. No, the whole area, the whole surface is a display. Maybe you have seen already this phone like in some shops that you can open and close, which is fantastic, I would say, and that's the future. I hope to see in the future like completely foldable or rollable displays. Yes, so maybe we'll have something like this, and we'll be able like to roll out the display. That would be great. If it could be big, that would be fantastic. So in between, I think the future is fantastic for OLED technology, for elastic OLED technology. Then we'll be able to use the displays more, maybe like wearable displays on our clothes. You know, there are cases like that. So we will be, yeah, for sure observing this market. What's there. Okay, so then we have AMOLED, and we have a super AMOLED, like we talked about STN and other technologies, like, you know, super twisted pneumatic. Here we also add this kind of additional words to just show that our display is more superior